Hi, in this video, we're going to talk about the lens equation. What these equations do is instead of drawing a ray diagram to find the image using either curved mirrors or lenses, we're going to actually use equations. So you'll have a choice. You can actually draw a scale diagram or a ray diagram like you have been doing all along to find the image, or you can actually use formulas. All right, and some people are going to like this idea because sometimes, people don't like drawing ray diagrams. So let's actually write out the formula. The formula looks like this: 1 over dO, and dO is the distance of the object to the lens, plus 1 over di, which is the distance of the image to the lens, is equal to 1 over f, which is the focal length or the focus, which is the distance from the lens to the focus. So let's write that down. dO is the distance from the object to the lens, and it's technically the center of the lens. di is equal to the distance from the object, not the object, that's the image, the distance of the image. That's why it's called I. So the distance of the image to the lens. And then F is we call the focal length. Focal length. And that is pretty much the distance from the lens to the focus. Perfect. Now you'll notice I talked about distances. So yes, it is going to be measured in meters. However, if you're measuring in centimeters, then everything should be in centimeters. Or if you're measuring in meters, everything will be measured in meters. So you have to keep your units consistent. Okay? Another thing you need to think about in these equations is the signs. So what do you mean by signs? Well, in math you have negative and positive, and same thing with in physics, or in this case optics, these equations have negative and positive values, which means different things. So for example, the object will always have a positive value because it's real. Okay, so I'm just going to write always positive. And I write a plus sign with a circle around it so you know that is positive. Okay, so positive. Now the image can actually be two values. You know that real images is something that you can actually see on a wall, or put the image on a wall or a piece of paper or a screen, whereas a virtual image you have to look through the lens, and you need to draw that little eyeball indicating you have to look through the lens to see the image. If you don't actually look through the lens, you'll never see that image, and that's why it's called virtual. So for real images it will be positive, and for virtual the value of di will be negative. So this here is going to be negative, negative. So it'll be a little a negative sign with a circle around it. Okay. Now focal length, you'll know there's two different types of lenses. There's converging lenses and there's diverging. Converging lenses will always be positive. Converging lenses will always be positive, and diverging will always be negative. Lenses are negative. All right, let's do an example. Now, some of you are going, okay, you know what? She is missing an equation because it says lens equations. We're first going to deal with this equation first, and then I will introduce the other equation after. So let's do our first example right now, and that will be, let's say we have a converging lens. So this here, f is equal to 3 centimeters. Okay, so the focus is 3 centimeters. So this here is a converging lens because it's positive 3, but we'll talk about that later when I put it in the formula. And let's say the distance away from this lens is 7 centimeters. So this is the distance away from the lens. So let's find the image. Where is the image located? All right, so let's first do a scale diagram. So in the previous videos, what we would do is we draw a ray diagram so you can actually find this image and where it's located. So I'm going to first draw that, all right, to show you where it is, okay, and then I'm going to show it to you mathematically, okay? And so let's draw out our principal axes, okay, and I'm going to draw my lens, and remember this is a converging lens, so it's going to look like this, the scientific symbol. Remember we also have a converging lens, so it's going to be a focus of 3 centimeters. So here is 3 centimeters, so this is F, and this here is 2F, F and 2F. Okay, and I'm going to have my image, or sorry, not my image, my object, okay, is 7 centimeters away. So 7 centimeters away looks like over here. And let's actually figure out, let's see. Let's draw a 2 centimeter high candle. That sounds like a good idea. So 2 centimeter high candle. So here's my candle, and it's about 2 centimeters high. Kind of idea. Ta-da! Yeah, that's about 2 centimeters. See? Perfect. A 2 centimeter high candle. I drew the midline over here because that will be exactly 7 centimeters. Let's double check all our measurements. So yes, this here is 7 centimeters. This here is 3, and then 3 again. Okay? All right, so this is the setup. Okay, and let's draw our ray diagram, and then we'll double check it if our ray diagram is correct by using the math. Or you could do it the other way around if you like. All right, so remember with the ray diagram, we're going to have principal or parallel to the principal axis. Okay, hits the center of the lens and then through F. Oh, my ruler just moved. Let's just double check that. Okay, it looks good. Okay, and then that's ray 1. Right? And this is the tricky part about drawing diagrams. So people don't like it because, you know, their ruler moves, or, you know, it's not exactly parallel. And that's fine. We've got equations, but we're just going to draw just to see where it is. So now we're going to have, okay, this here is ray 2. And remember, ray 2 is through the center of the lens, like so. And let's don't forget our little arrows on our ray diagrams. Okay, and so our candle looks like it appears over here. Okay, and like so. I'll just draw it up approximately. Okay, so there is our candle. And let's measure, or let's label. This is the object, and this is the image. You'll notice the image is real because it's on the opposite side of the lens. We don't need an eyeball to locate it because the rays actually do intersect. Okay, let's actually label some other things. So this here from the center of the lens to F, that's 3 centimeters from there to there. DO is 7 centimeters. We measured from here to the lens to the candle, and now we can actually measure. So where is the image located? Well, let's take a look. It's located, let's measure it. It looks like 5.3 or 2, 5 point, oh, yeah, let's do 5.3 for now. That sounds like a good idea. Okay, so when you measure it, there's two ways to do it. Okay, and this is using the diagram. Using the diagram, we measure 5.3 centimeters. Okay, we literally measure that, so I'll show it to you right there. 5.3 centimeters. Okay, so now let's use the formula. Let's see what we're going to get, and let's see if we actually get close to 3.5 centimeters. So let's take the piece of paper and we'll bring that over here, and let's write our formula down. Okay, so remember our formula is 1 over dO plus 1 over dI is equal to 1 over F. Okay, so dO, let's list our variables. dO is equal to 7 centimeters. Okay, it's plus, so I'll just leave it like that. F is a converging lens, so that's 3 centimeters, and we need to figure out dI. Let's plug it in. 1 over 7 plus 1 over dI is equal to 1 over 3. So when I work this out, I'm going to have 1 over dI is equal to 1 over 3 minus 1 over 7. And some of you are going, oh my goodness, I got to remember how to do fractions. Okay. No, don't worry. You don't have to do any fractions because nowadays we have something called calculators. All right. So this is how you would calculate this. Now, according to your calculator, all calculators will have a 1 over button, okay? Some people like to use the fraction button, but the 1 over button is way better, okay? This 1 over button is located right there, okay? Now, some calculators are going to be a little different than others, so let me write that down. My calculator, the 1 over button, or the, 1 over button looks like this, okay? Some other calculators, the 1 over button looks like this. So pick, or not pick, but find which button is that applies to your calculator. Okay, so this is how to work the magical 1 over button. Okay, so I have 1 over 3 minus 1 over 7. So this is how it works. I'm going to write 3. And then I want it 1 over. So I'm going to press this button. Oh my goodness, look at that. And it says 3 negative 1. That means in math that it is a fraction like this, 1 over. Okay? Then minus, then I press the 7, then I press the button, all right, the 1 over button, and I'm going to get, woo, look at that, a really fancy schmancy answer. Okay? So let's go over that again. All right, just to make sure. So 3 and then inverse, it's called an inverse button, minus 7 inverse equals. Okay, so now I know that 1 over dI is equal to 0.190 blah, blah, blah. We'll just keep 3 digits for now. Okay, so far so good? All right, next. This is 1 over dI, and it doesn't look like 5.3. So we need to actually flip it or invert it, okay? So when I do that, what happens is in mathematics, what we do is we don't want dI at the bottom. So we're going to multiply both sides, okay? So if I multiply both sides by dI, I get rid of that and I get 1 over 0.19 dI, okay? Now, that's not good because I actually want just dI. So let's actually multiply this now to get rid of, or not multiply, divide, to get rid of that number. So if I divide both sides by that, that gets rid of that. And now I have di is equal to 1 over 0.190. Okay, so what does that mean? Basically, 1 over di, to get this number or to get that number back, you're just going to flip it. I like to call this the flip button because you're literally flipping, all right? So instead of you wanting 3, you're going to flip it. Okay, so in here, I'm going to flip it. Wow, how convenient. We have a flip button, which is this inverse button or the 1 over button. So you see on my calculator, I didn't erase it. I'm going to do this. I'm going to press that. And oh, it says my answer is going to be flipped. Equals, oh, look at that, 5.25. And you'll notice when I was drawing my diagram or measuring it, I was struggling. I'm like, could be 5.3, could be 5.2. Wow, 5.25. Look how accurate that is. That is so awesome. So let's bring it over here. di is equal to 5.25 centimeters, which is the same as this one. Oh, let me grab the piece of paper right here, which is the same as this. And actually, let's actually measure it properly. Too bad I can't zoom in. But yeah, that looks pretty dead on between 2 and 3. It looks like 5.25, okay, which is pretty cool. And that's how you do the lens equation. But remember, like I said, there is one more, okay, equation. So here's the other equation. How high is the image, or the size of the image? So let's actually write that in the question over here. I'll add it in. So part A, and then we have part B, okay? What is the height of the image? Okay, so let's draw it out. Well, we already drew it out. Ha! I'm going to measure it. So let's measure it out. So when I measure it, I get, let's see, it looks like 1.5, doesn't it? It does. Okay, 1.5. Okay, so here we're going to write using the diagram, and same with this one. We measure DO as this, and di, the image. This, because this is the image, and this here is HI, the height. The height. Now in this case, the height is going to be negative. Okay. Some of you are going, what? Negative? Like, yes, I'll explain that in a second. It's negative 1.5 centimeters. So remember in math, you have positive and negatives. Well, just think about it this way. This top part, that's the positive area, and this bottom part is the negative area. So yes, the height is technically negative, okay? All right, so let's actually go back to this lens equations, because there are technically 2 of them, and write down the second one. Sometimes we call this equation the magnification equation, or just called magnification. So magnification is equal to the height of the image divided by the height of the object, and that is going to equal to negative the distance of the image over the distance of the object. Okay, and so that's the second equation. So let's actually write that down. HO is the height of the object. Okay, and again in centimeters or meters, depending on the units, as long as the units are consistent. And HI is the height of the image. Now, let's do plus and minus signs. Keep in mind that if the height is always positive, and we usually draw the object positive, okay, so this here is typically positive. I should put S on the always up here. Then the image, for a real image, it's always inverted, okay? So inverted means that it's going to be negative. Inverted is negative, and then erect or upright will be positive, okay? And so in this case, our candle is inverted, and so it will be negative. All right, so let's go back and let's calculate the height. So we're going to calculate the height right now, and we measured the height to be actually, when we drew our object, the height in this case, we had HO is 2 centimeters. All right, if you can't remember that, let's double check it by measuring it. There it is 2 centimeters. And then we measure the height of the image as 1.5. Let's double check our math. Okay, so this is for part B. So this is part A. So for part B, HI over HO is equal to negative DI over DO. Let's plug everything in. HI is what we're trying to solve for. HO is 2 centimeters. Okay? Negative DI. Well, DI we calculate to be 5.25. So let's write that down. 5.25 centimeters. Remember, it's a real image, okay? So yes, DI is positive, but there's a negative sign in the formula, so you got to keep that negative sign in there. DO, DO is 7 centimeters, so we should write that down. Perfect. All right, to solve this, remember, we're going to crisscross, all right? Cross multiply, so this is going to be negative 5.25 times 2 centimeters divided by 7. All right, so now let's work that out. We have our calculator there, and let's get the actual value so we can see it. Perfect. Negative 5.25 times 2 divided by 7. Oh, look at that! 1.5. That's so cool, and it's negative. That means it's upside down, and that's cool too, because that's what we got in our diagram. Okay, so let's bring it over here. This is going to be negative 1.5 centimeters. So yay, our diagram's right, or yay, our math is correct, or formula is correct. So on a test or a quiz, you have a choice. You can either solve it by equations, or you can solve it using diagrams. Your choice, okay? And the beauty of it is that if you know how to do both, then you can double check your answer, which is kind of nice.